You guys are doing that still? Yes.
I want to.
Oh, sorry. Oh, so for each one explain in that instance why. Don't just give me a definition, but for each problem tell me why it's a function or why it isn't a function.
So
Yeah.
we should write again.
For each one, don't just state the definition, but say in this case, this had two outputs, so it's not a function. So that's
Okay. And then
each
after
case you got to tell me why.
finish it,
Hmm?
I have to give it
Yeah,
to-
and they just like any homework, yeah. I like it. That'd be so funny if you're all like texting each other. So I'm going over there in the third row. Okay, then. All right. So no questions from homework stuff? You guys are doing it, of course. You're smart. You know it makes sense. Okay, good. I want to do just a few more word problem stuff, and then we're going to get into graphing, the next thing. And normally, word problems are the top of students' hate list. Hopefully, I don't know, that you feel a little bit better about it. I don't know. And you're like, oh, we'll find out. So, and then right after word problems comes graphing normally, in that list of hate, right? I understand it's, anyway, we'll get there. Yay. So the last type of word problem, if there's no specific questions, are distance, rate, time word problems. I kind of gave that away earlier, I think it was yesterday. What's the formula for distance, rate, and time? How do they relate? Yeah, dirt, right? And you all do this already. I mean, if you're traveling 50 miles an hour for a couple hours, how far did you go? 50 miles an hour, a couple of hours. How far did you go?
50 miles.
It's going in circles.
You said 50 miles?
I've gone nowhere, Jeff. Huh? 50 miles an hour for 2 hours. How far have you traveled? 100 miles. I like it. I like it. Even if you went a big old circle and stopped right where you see, I don't care, you still went 100 miles. Right? So rate times time. Rate is, in general, it's the amount that something changes per time. And for traveling in a car, that's going to be your speed. Times time gives you the distance. I like it. I like it. So it's not amazing. So what's really nice with this kind of problem, so let's see, let's look at an example kind of problem they would have. Let's see, what do you want to say? A boat, let's see, let's do this one.
An airplane. Spaceship. Horse-drawn carriage.
I travel first leg of a trip.
This one.
60 mile an hour. And the second leg, I hit traffic, so that's a 40 mile an hour. All right. I think this is too free. Yeah, okay. The total time it took was 6 hours. Let's see, what else was there? Yeah, okay. And then the total distance was, let's make something more chef, that would be neat. 340 miles, let's say. Okay. Whew, yes.
Do we have enough information?
Yes.
Because are both legs equal size?
Nope.
Cool.
Sweet. So the question, I didn't even put the question yet, right? The question is, how long was each leg? Right? gosh. Really gave up there in the last sentence. How long was each leg?
How long each leg?
How long each leg is? Here's what you can do. You don't have to do what I'm about to do. If you've seen this kind of problem before, you kind of know how to do it, you got your own way, keep it going. I'm not telling you you have to do it this way. But this way is really, really useful for organizing a lot of information. There's a lot of information, right? Do you guys see the two parts of this problem? It's almost too obvious. There's two big parts of this problem. First leg, second leg, right? So for most distance rate time problems, you're going to have two parts. Upstream, downstream. I went to Jack's house and then I came back. So two there and back and so forth. This is going to be two parts. So let's say first leg, second leg. Aw, how retired you. Thank you for your service. All right. And then on top you put the formula. Distance equals rate times time. And then you just fill in all the boxes with what you know. All right. So, for example, what do I know for a damn sure that I can just put in directly? There's no need for a variable. Yeah, the rates. So the first leg, 60, second leg, 40. Now, here's where it gets a little bit trippy. That 6 can't go anywhere up there. And I always get somebody put 6 and 6, and then I'm like, so it took 12 hours? But it's supposed to take 6 hours. And then they put 3 and 3, I'm like, well, that's a little bit better, but still no. How do you know it took equal amounts of time? Yeah, so one of them's going to be x. And we already know how this works. What is 6? Isn't that a total time? So if one of them, which one? It don't matter. One of them's x, the other one's got to be
6 minus 6.
6 minus x. I like it. Now, here's the nice thing. There's still something up here I haven't used yet, right? But that's going to be where the equation comes from. The minute you've got it filled in, so you only have 2 spots left. So pretty with me so far. All I did was put what I know, put the variables. Now I've got 2 spots left blank. What's that spot become? Rate times time.
60x.
60x. You guys see that? If I went 60 miles an hour for x hours, I went 60x miles. So what goes here?
4x, 6 minus x.
And do you see how now this last thing we haven't used yet sets up the equation? Right? What has to happen then? Yeah, the two distances, here's how far I went the first leg, and here's how far I went the second leg. Together they're supposed to make 340. Let's see if Jeff made an equation that makes any damn sense. Let's see. It's always exciting making something up out of nowhere. I got it to work in my head. Let's see what happens on paper. Huh? I'm a math boy. It's my one skill. This will actually work out. Yay. Let's find out. This is a little bit evil and I don't seem to care. We'll find out what you guys see. So now it should be the easy step, right? And that's why you guys want to get here so fast, I think, is because that is the relatively easier step. But that's why you shouldn't be able to get there that fast, because it's the hard stuff before this. So of course it should take you a little while to get to this stage. Now it should be easy, right? Distribute. Then I can, yeah, I get how many? 20. Please, dear God, please. A lot of people are doing this, so I'm not talking to anybody specifically. This doesn't make any sense. That makes 0 sense. Nothing. No sense. You added 80x to one side, left the other side alone. You only do that when you have to get across the equal sign, right? That's the only way you can move stuff across the equal sign is to do the same thing to both sides. You just overloaded one side. with a bunch of frickin' 80x's. It's like, what the shit? No. Get out of it. 60 at my 40x. 20x. Then I can do this.
Plus 240.
Minus 240. So equals
90.
100.
190.
X equals 5. I like it. Now, it did say this was evil, and it's not really. This is beautiful, come to find out. Because what's that mean? 5 what?
Hours.
5 hours. Because X represents time of first leg. You see how cool that shit is? What is it? What's the time of the first leg? Okay, I can't go wrong. Well, what's my question asking?
Hours each leg.
No.
Distance.
Well, I could be a little bit more specific about length. But how long was each leg in miles? Right?
Okay.
Not how much time did each leg take. So this took 5 hours. This is 5. So this would be what?
1.
1. So how long was this leg?
300.
Yes. What is X?
5.
5. 60 times 5?
6 times 5 is 30. You just add a 0.
Exactly. So 300 miles. And this one was?
40.
Yeah. X is 5. 6 minus 5 is 1 times 40 is 40. And why does it make sense? Because these two do make 40. You can kind of check it right there. Maybe. So the chart's not magic or shit, right? It doesn't do stuff for you. It makes it easier to see all the parts at once. Because there's a lot of shit going on in this problem. Okay. All right. Let's actually let me pull one up out of the book here. Let's see what theirs looks like. Come on, we can do this. There you go.
Beautiful.
Alright, look up. This is always exciting. Let's see what they got here. So this is currently, we're getting into section 3.5.
This one.
So let's see what they got. Here they got the little up there. The chart we just did, right? They just put distance at the end, it doesn't really matter. Okay. Yes.
305.
Which one?
305.
305.
The final one.
350?
305.
Oh, from the homework. Maybe. Maybe. We'll see. Let's see what one of these here. Here we go. I love it. See this one, 3.95?
Try it.
So go ahead and try to set that up. You guys see that all right?
No.
Sorry.
We need lights.
Oh shit, the light's not really helping. Can you, yeah, do that one, and the one next to it, and then the one right below that one. Yeah. Do your job. Holy shit.
Do you think it's big enough?
Is it all right? Large type. Wayne and Dennis, that's what we're doing, right? Should have been Garth, but that's all right. Now, I want you guys, so you've read through that problem, right? So everybody read through that? Do you guys see there are two things they just tell you? There's nothing unknown about it. What two things do they just tell you? Yeah, Wayne took 2 hours, Dennis took 1.5 hours. Right? So now you make your little chart, distance equals rate times time, and you start filling that in. And what's one, each row, of course, the first row is going to be Wayne, second row is going to be Dennis. I like it. Maybe. So just try to get that chart filled up as much as you can, and then I'll catch up to you. Here, those of you at home, we're doing that one way over there. All right. Better for good reason. That's going to be a neat part of it. All right. I'm way the shit over there. Shit. Catch up together. So obviously, Wayne, you could put 2, right? And Dennis, you could put 1.5. Now, what's my variable going to represent? Yeah, the speed. Who's going to be just X?
Wayne.
Yeah, because Dennis is 7 miles faster than Wayne. So I got to know Wayne first. So Wayne is going to be X mile an hour. So Dennis is going to be good, or X plus 7, either way. That's the one that doesn't matter. The subtraction, oh shit, that matters. Let me stop for a second. Is that cool?
Yeah.
Same idea we've done before. It's just there's a, and again, you don't have to use a chart, but it makes it easier just to organize a lot of information. Okay. Do I have 2 blank spots left?
Yes.
Kick ass. So then how do I fill this guy? No way. So distance is rate times time. So 2 times x. Here this would be, and you could be nicer to yourself than I was and leave yourself more room in there, but okay. So not every problem, this is, you guys, if I say this, let me see, that problem's the same as this one. Because I'm gonna add the distance, or what's gonna happen now. Let's see what they say. Oh, I like it, this is perfect. All right, I like it. So when did Dennis like to ride the bike path? From Riverside Park to the beach. So this is not going to be an addition. So this is, I'll take that back, what I just said. Wayne and Dennis, they both like to ride the bike path from Riverside Park to the beach. So what's got to be true about their distances that they traveled then?
Oh, they're equal.
They both have to be equal to each other. So the last problem that I made up, and again, this is another kind of problem, is the 2 distances equal the total. But here, how do the distances relate? How can you guys tell it's the same?
Because they both ride the same path.
Because they both went the same way. They both rode the same path. And we're going to assume that neither one did this thing. It's longer, algebra people shut up. So the US just went straight there, right? Okay. So, how do I write the equation then? 2x equals
1.5 times x plus 7.
the equation comes from the idea about how the parts relate. Here the parts added to make a total distance. There is the same path, so the distances have to be equal to each other. Crazy. Very much. So later this semester, we'll actually have some of these be empty. The reason that's not going to happen to us yet is because they would have equations like 2 over x plus 5 equals 3 over 2x minus 7. We don't know how to handle variables in the denominator yet. Not really. So it's not going to happen. So now it's the easy step, right? I know there's a decimal there, but you can kill it if you want to. Poor little dude. Or not. So distribute 1.5x plus 10.5. Subtract. Divide. X is 21. What's that mean?
That's not miles per hour, is it?
Well, you tell me. What do you think?
30 miles per hour.
Yeah, so they went miles per hour, yeah. He's on a bike. Motorized bike. So this will be, what was it, 21 miles an hour for Wayne. And then how about Dennis?
28 miles per hour.
Yeah, because it's plus 7. 28 mile an hour. Maybe it's downhill for Dennis.
Dennis just likes going on the edge.
Yeah, this goes flying into the ocean. I made you up. Yep. So part of this, so the chart thing is a new idea for this class. Some of you guys might have seen it before. But the only thing, it doesn't change the fact that something is still going to be x. The other things, something else is going to build off of that. Right? The kind of new thing is there's this equation in the background that tells me how everything within each relates. But the chart, again, helps me use that correctly. All right. Okay. I love it. My math teacher, I'm used to this, but some of you guys look like you want to hurt me. And just keep that in your head. Have little fantasies, don't bring them to life. Okay. Blah, blah, blah. Let's see, what's nice when it's different. Oh. Okay, I like this one. I would. So here, let me show people playing along at home. Christopher and his parents. Okay. So with this kind of problem, with distance, rate, time problems, you got the chart you can create, start to fill it in. There almost always will be something they just tell you straight up, no unknowns to it. And then there's going to be another one that's involving a variable that you don't know. This one, the equation might be a little bit funky, so let me, you guys get the chart filled in, and then I'll try to catch up to you. Huh? What's about what?
His parents were really breaking
Well, remember, neither one of them are going the full 115, right? You guys see that?
yeah.
They live 150 miles apart, so they are going to meet, so neither one goes the full distance. But his distance plus parents' distance has to make, see there's a, you guys see that? So this is not like Wayne and Dennis. Wayne and Dennis just, they both started in the same place and they both ended in the same place, and that's why their distances are equal. Here, there's so many miles apart, so when they meet, each person went a certain part of 115. So they have to recombine to make 115. Okay, I like it. Some of you guys imagine great bodily harm occurring to me. That's all right. Keep it in imagination land, kids. All right, let me catch up to you.
Okay.
So we got, what's his name? Christopher and parents. By the way, real quick, not to screw it. It's a stereotype, but who cares? Old people, how do they drive? Slow. What's really funny is they don't drive slow because they're old. They're old because they drive slow. They survived. So when I see somebody, an old person going crazy, I'm like, you're one of the few that managed to make it through. Just remember that, kids. All right. So definitely, what do we know just know? What do we just know? Yeah, so Chris, 1.5 hours, and parents, and sorry, Jeff. That's all right, I got you. I got that phone that can take it.
That's gonna get a lot of views.
That's when the quake hit.
Ethnic math fail.
It was the big one. Sorry. That is definitely going to be weird.
Very professional, of course.
Oh, please. Professional? That word does not belong near me. All right. So what's the variables involved? It's going to relate to rate. I like it. So who's going to be just whatever letter really, but let's say X.
Parents.
Yeah, because Chris's speed was something parents. Okay, so the parents, if I call them X, I can call Chris's speed X plus 10. Now, I want you to realize we are too soon in the course to do a little more complicated problems. We're going to see the same thing later, but we're going to have, like, these two might be open instead of these two being open. You guys see what I'm saying? No? Everybody see how these are empty?
Yeah.
So, of course, I know how to fill them in because I multiply this and this.
Yeah.
What if these two were empty and these two were filled? Time equals distance divided by rate, and that's when I'm going to have variables on the bottom, and we're just not quite fully there yet. So you're like, that's fine. All right, that's going to happen later. Oh, yeah. But what do I put here for now?
1.5
X. X. Yeah.
Oh, one.
Okay, I like it. Way to keep it simple, parents. I like it. So then, what? Now we already went over this, but just tell me, what's the equation going to be? What's the relationship between the distances? Yeah, together they went a full 115. Neither one did that by themselves, but together they did. Oh. So they were 115 miles apart. He went, they went. So together, this plus this has to make the full 115. That's another kind of distance rate time problem. So yeah, 1.5 times x plus 10 plus x equals 115. Good. But see, then you can see why I'm going to get a student and say, well, why did we add it and the other one we set them equal to each other? You're just doing weird shit, Jeff. And I'm like, it's always the idea in the problem that is telling me how to set this up. It isn't just put it down and pray, right? It's going to be an actual reason to put something down. And now it should be the easiest step again. All right, what do I get there? X, yeah, plus 15 plus x equals 115. Those look made for each other. Aw. What's 1.5x plus x?
2.5.
That's crazy. It's 100. Yeah, so you divide by 2.5. 100 divided by 25 would be 4, so 100 divided by 2.5 is 10 times bigger, 40. Or just do any calculator. 40, and what's that mean?
It means
Rate.
parents went 40 miles an hour.
Parents were going 40 mile an hour, and then Chris was going 50 mile an hour. I like it. Is that what he asked for? Yes. There you go. Sweet.
We're the smartest class you have. Figured that out so quick.
And psychic too. 'Cause I don't know how you know how many other classes are doing.
But that might be true.
Oh. It's my stats class. I love you guys too. But step up. Alright. They don't even watch their videos. Maybe some of you do. I don't know.
Tell them if they see a code word that's in one of these videos, they'll get extra
Telling my
credit.
truth. All right. Are we done? We got, you guys see? So we did answer average speed of him and his parents. Bam. And you can do it pretty much exactly like this because that's Chris, bam, and that's parents, bam. I like it. I like it. So what you said. Oh man.
And you can check because like 50 times 1.5 is.
Oh yeah. You can check. So 50 plus 10 is 60. 1.5 times 60 is 3 times 30 is 90. 1.5 times 60. So it'll be 90. This is going to be 40, right? I don't know if that tells you anything.
No, that was, I think, wrong.
Maybe it is wrong. Let's see. If
Wouldn't we just
oh, I'm
multiply the
sorry.
rate
That'll
times the
be
time?
40 plus 10. Yeah. So x is 40.
No.
40 plus 10 is 50. 1.5 times 50, 75.
Yeah.
This is
That's
40.
40.
75 and 40 makes 150. Okay. So you can't always check it like any equation. All right.
So, example of 350 is good.
Where? Which one? Sorry.
350. You don't have
350.
to-
Where are you? There it is. Oh. All right. Yeah. Okay.
Let's find something different here.
All right, this will be the last one of these, and then we're going to get into some graphing. Because this is kind of like the last category of these. So try to set up the chart for this problem up there. Two drunk drivers. Any wonder why I don't teach English?
I don't wonder.
No, you shouldn't. You should not wonder.
I really like how like it's a good balance in this class of just like you teaching us math and us roasting you, and some self-roasting there, but
All right.
it's really good. It's really
You
good.
want to? You sure you want to bring up the roasting thing? Because then I can roast you guys also. So now, this is almost exactly the same as what we just did. So the one we just did, they met somewhere. So the distance this one traveled plus the distance this one traveled was the total distance. Aren't they doing the exact opposite in this problem? They're both starting in the middle. One goes west, one goes east, right? And still, so then the distance this one travels and the distance this one travels, if you do what, they should make what? Add them, they should be 325. I like it.
We don't have time.
Oh, she did? Not that I saw. I didn't see anything. Not sure what they would look like. Oh, they're right here. You got them? Thank the gods. Sure, no problem. I thought they were here to get that. Sure. Hey.
Right.
I was going to get my thumbs broken for some money bar, but not yet. Not today. All right. It's not true, kids. I'm okay. I'm going to come in with, oh, a little cast. So, same idea, right? This is going to be, let's call this one westward truck dude, and this is going to be eastward truck dude. Or dudette, I don't know. Let's see, distance equals rate times time. What do we know for sure?
The rates.
Rates. So westward dude, 70, and eastward dude, det. Say this is a dudette, that's a dude. All right, and what else do we know?
Total.
Say again? Yeah, we know the total. So that's going to be where the equation comes from, right?
We don't have time.
What are they asking about? Yeah, how long will they travel? They're asking for